For a while there, it felt like AI was the only story in tech. But while we were all looking one way, another revolution, a totally different kind of computing, was hitting its tipping point. That year was 2025. This is the story of how quantum computing jumped from the pages of a physics textbook and into our world. And it's really hard to overstate just how big this shift was. I think the Quantum Insider captured it perfectly. They called 2025 an inflection point of inflection points. I mean, what does that even mean? It means the dominoes started falling so fast that the entire game changed. The conversation wasn't about if this stuff would work anymore. It was about how fast it was all going to happen. And this wasn't just some niche thing happening in tech circles. No way. The United Nations itself, the actual UN, officially designated 2025 as the International Year of Quantum. That's a huge deal. It's a signal to the entire planet that this technology has finally arrived on the world stage. Okay, so what is the big deal here? It really starts with a concept called superposition. Think about the computer or phone you're using right now. It runs on bits, and a bit is like a light switch. It's either off, a 0, or it's on, a 1. Simple. A quantum bit or a qubit, well, it's a whole different animal. It's more like a dimmer switch. It can be a 0, it can be a 1, and it can be pretty much everything in between, all at the same time. This weird ability lets it process a staggering amount of information all at once. And if you thought that was strange, then there's entanglement. This is where things get truly powerful and kind of spooky. When you entangle two qubits, they become linked in this deep, mysterious way. Whatever happens to one, instantly, and I mean instantly, affects the other. It doesn't matter if they're on opposite sides of a lab or opposite sides of the universe. This bizarre connection is the secret sauce. It's what gives a quantum computer its mind-boggling exponential power. So, with that kind of power on the table, what happens next? A race, of course. A furious, global race to build the hardware. And 2025 was the year that race went into absolute overdrive. And what's so fascinating is that all the major players were placing different bets. You had China's Zhuchangzi 3.0 processor, which was all about raw, unadulterated speed. Then there was Google's Willow, which hit a huge milestone in error correction, a massive problem in quantum. IBM's Nighthawk pushed for more complexity, while Quantinuum's Helios was focused on being the most accurate commercial system you could get. It was this incredible strategic divergence. Who would win, the fastest, the most accurate, or the most complex? And the performance claims that came out were just staggering. Researchers in China said their Zhuchangji 3.0 chip was, get this, 1 million times faster than Google's machine on certain tasks. 1 million. That's not just an improvement, that's a whole new paradigm. But the race wasn't just for the big tech giants. Oh no. Researchers at Caltech took a completely different approach, unveiling a massive 6,100 qubit array that was built using neutral atoms. It was proof that the quest for a powerful quantum computer was happening on many different fronts at once. Meanwhile, Microsoft decided to play a whole different game. Instead of just building more of the same error-prone qubits, they revealed a brand new type of qubit, the topological qubit. The whole idea here is to build a qubit that's naturally resistant to errors right from the start. It was a huge, high-risk bet, but if it pays off, it could change everything. Of course, all this incredible hardware is just a cool science project if it doesn't do anything, right? Well, 2025 was the year quantum computing made the massive leap from the lab bench into the world of business. The money started pouring in, and companies started solving real problems with it. And just how serious was that money? How about a $1 billion deal? That's what Quantinuum landed in a joint venture with Qatar's Al Raban Capital. You don't see billion-dollar deals for science experiments. This was a clear signal that quantum was officially open for business. The private markets absolutely agreed. Take a look at this. In just the first 9 months of 2025, funding for quantum startups nearly tripled the total for all of 2024. The investment dam had well and truly burst. And it wasn't just venture capital either. Wall Street giants like Morgan Stanley started taking major positions in these companies. When the big conservative financial institutions start writing checks, you know an industry's arrival is for real. The smart money was officially flowing. But was it actually doing anything useful? Absolutely. In 2025, we saw the first real, concrete signs of quantum advantage. That's where these machines actually outperformed classical ones on real business problems. HSBC improved its bond trading predictions. Ford Otosan cut a scheduling task from 30 minutes down to less than 5. ANSYS sped up complex simulations. This was the proof everyone had been waiting for. So all this progress in hardware and investment created a completely new reality. The breakthroughs started to reveal the tangible, near-future implications for pretty much everything. Take the quantum internet. For years, it was a cool idea, but you could only send a quantum signal a few kilometers before it died out. Then, a team at the University of Chicago developed a new method that could extend those secure quantum links across entire continents. Suddenly, a global, unhackable quantum internet seemed like it was actually within reach. How'd they do it? Well, instead of the old melting pot method of just mixing stuff together and hoping for the best, they used a technique that's like 3D printing, but at the atomic level. They could assemble their device atom by atom, creating this unprecedented level of purity. And that's what made the long-distance connection possible. But with all this incredible power comes a pretty serious risk. Right now, our entire digital world, your bank, your messages, government secrets, is protected by encryption. And that encryption relies on math problems that are just too hard for normal computers to solve. The problem? Quantum computers are specifically designed to be brilliant at solving those exact kinds of problems. And that threat suddenly got a lot closer in 2025. A paper from a Google researcher showed that, thanks to better algorithms, breaking our standard encryption wouldn't take 20 million qubits like we used to think. The new estimate was less than 1 million. And with the hardware race moving so fast, that number felt terrifyingly close. Now, the good news is people aren't just sitting back and waiting for disaster. The race is on to build a quantum-proof defense. A new generation of quantum-hardened security is being created, designed to be unbreakable even by quantum computers. We're essentially using quantum's power to defend against itself. So where does all this leave us? Well, the events of 2025 marked the beginning of a brand new era. The theoretical became practical, and the future of computing was rewritten right before our eyes. Looking back, you can see 4 massive shifts. The hardware race exploded, and we realized there were multiple ways to build a powerful quantum machine. The money and the real-world applications surged, proving this thing had real commercial value. A global quantum internet went from sci-fi to a real possibility, and the need for quantum-safe security became an urgent, unavoidable priority for everyone. One investor put it in a way that I think is just perfect. He said, people are going to underestimate quantum computing, that it's like ChatGPT. You hear about it, you think it's kind of interesting, and then one day, it's just everywhere, changing everything. So the conclusion is pretty clear. Quantum computing is no longer a distant dream on a whiteboard. The technology is here, the investment is real, and the implications are absolutely massive. The quantum era has begun. The only question left is, are we ready for what's coming next?